So, hello everyone. My name is Amin Araki Husseini. Today, so thank you for joining us for this session. We've allocated 40 minutes for this session to talk about power to power. So, power to power, when we say power to power, obviously it means power to hydrogen and then hydrogen to power. So what we know in the industry today is that the two ways, let's say, to produce power from hydrogen is one, let's say, through fuel cells, or the second way is the blend of hydrogen and gas, let's say, the combustion process in the existing gas turbine power plants. So we'll see today, we'll cover with our experts the benefits and challenges of this application. So I'm going to introduce our panelists. So we have Miss Hanan Al-Hamrawi. So Hanan is the VP Industry at HDF Energy. She's in charge of the industrial business unit at HDF, which manufactures containerized multi-megawatt hydrogen fuel cells. So we have also Mr. Nordin Fetian. So Mr. Nordin is the director of production at ONI, the Moroccan national utility. So he's in charge of the operation of all power plants, including conventional and renewable energy power plants. And his main duty is to assure the continuous balance between production and electricity demand. So, and we have also Mr. Raúl Manzanas. So, Mr. Manzanas is the development director at Acciona Nordex, and he has occupied multiple roles within Acciona throughout his careers, including he was head of O&M. Being in charge of more than 12 gigawatts of projects. So I will first give the floor to Mr. Fetian. So Mr. Fetian will present us the main benefits of this technology of P2P in the energy sector. And he will also talk about the projected costs of the storage solutions, and also of the challenges that this technology faces.
Okay. Assalamu alaikum. Bismillahirrahmanirrahim. First, thank you very much, my friends. I am really glad to be here today in this very interesting event in order to share with you some big questions regarding this topic, power to power. So before introducing the topic, I want just to share this map, which shows the potential of renewables in Morocco, and also the projection, the targets objective in 2030. So Morocco, alhamdulillah, has big potential in renewables. I prefer to introduce the topic with this image in order to link between renewables and green hydrogen, because hydrogen can play a strategic role in system balancing, because we are aiming to reach more than 52% of renewable energy in energy mix as installed capacity, and as a transmission operator and also the system managers, we have to balance the grid, and in some emergency situation, and also to cover all the intermittents and the variability of renewables. So the power to power, it's not only power directly to electrical power, but we can find a lot of form of this power, maybe electricity power or heat also to switch between lots of forms of energy as liquid, heat, and also electricity. But in our topic, we will focus only for this loop power to hydrogen to electrical power. Just to what is the need for hydrogen as a flexibility? Hydrogen can it's considered as the most promising energy source, because it's not only a source of energy, but it's known as energy vector. It can be used for long-term storage, and also it will cover medium and huge capacity, what is needed for the energy transmission, as maybe for smoothing or also for balancing the system. Also, the hydrogen, as is known, it's storable and it can be used from location to other. It's transportable between areas, and also it can be converted to another forms. So this is all the features or characteristics of hydrogen as a main actor or promising energy source in any energy system. Among the main benefits or the drivers forces to consider hydrogen is the storage energy system in the future, because we have now several countries are looking for energy sovereignty, to be more independent from political or international variability. And also the hydrogen is considered as an energy transition case to decarbonize the industry, to decarbonize also the power generation in several countries. Also, we are leading now some technological advanced and technological development regarding electrolyzers in order to produce hydrogen at the lowest cost if it's possible. The benefit to use hydrogen as a power generation for the future, because it's, as I mentioned before, it's a long-term, it's a long-term storage rather than short-term storage. Also, it can transfer energy between seasons and also between location. So you can transport energy, hydrogen from area to other, and also we can store this energy, and also to satisfy the need of network between seasonality. Also, energy, as we know, renewables, they have a lot of advantages, but there are some constraints to be covered. The main one is the intermittent and the variability of this energy. So we need to, for the system stability, to have a hydrogen storage as a main component to cover these issues sometimes in some primary response, and also for secondary response of the system. This is why hydrogen is considered as the main storage capacity in order to help the transmission network to do its job correctly. Here I am. The schema here is to deal about the main constraint of the whole loop of the power-to-power technology. So what we call the round-trip efficiency. The round-trip efficiency, because for every steps of the loop, we are losing some amount of energy in order to fulfill this loop. So this, comparing with the others, maybe technology, the power-to-power technology are facing or will be faced the round-trip efficiency rates, because it's around 30 to 40% at maximum, comparing with other technology as batteries, as hydro pumping storage. So it's facing this gap. Regarding the price of the P2P technology, the price to produce electricity from hydrogen coming from green renewables we have lots of costs to cover, including the installed capacity for all the equipment, electrolyzers, BOP plants, and others. The electricity cost, the initial energy used for transforming electricity to hydrogen is the main cost to cover, and also the operating costs during all the life cycle of the project. So the cost of P2P loops, it's mainly the cost of hydrogen generation, and its speed or its prices between electricity costs, which more or less 60 to 70% of the level, the total cost, and 30 to 40% is for all the capex, including electrolyzers, and OpEx, including the operating, maintenance, life cycle, and so on. But this is why the cost and the round trip efficiency remain the biggest drawback to overcome. And if we can have an electricity price at the lowest price, the lowest cost possible, and also to lower the capex of electrolyzer, we can reach some very interesting price of hydrogen. Just to show some projects at the cost, and also the comparative between all the technologies. We know that levelized cost of storage is the most indicator to assess and to evaluate the cost of the whole process, including investment, including operation, including all the cost during the life cycle. So now, and still now, the green hydrogen as a storage is facing really very competitive within the other technology. And also it will be also for this next decade having some disadvantage regarding the others. But this levelized cost of storage, it cannot be used only to evaluate, because we are not evaluating some mature technologies, and hydrogen technology which is really under development or demonstration project. I want to just to compare this situation with the situation of renewables 10 years before. Nobody can imagine that renewables can have this falling generation cost. PV and wind energy were collapsing from between 40 to 80% of initial costs during this last decade. So we are confident that using best development projects, using also low cost energy, hydrogen can be competitive in the future. So some technical and operation challenges facing this technology. It's the most one is costs and the performance. Competitive system costs still now until now very high to overcome. Also for performance and safety. So hydrogen safety, we have to carry this area, because we are operating hydrogen, and we have to look for this hydrogen safety. Infrastructure, we have some lack of infrastructure, including pipes, including also all the transportation infrastructure. Regulation also are not really technology and the advanced regulation, so we have to put some regulation and standardization in order to be in phase with the hydrogen which come. And also for the valuation. Valuation is include all the incentives, all the pricing model, the offtake, in order to have this competitive advantage of the hydrogen in the future. So as just I want to sum up with some recommendations in order to encourage infrastructure, including stack, and also all the equipment development. Planning and integration is really a big question, because we have to plan all the action between all the actors, system operators, power plants developers, also storage system development, in order to reach and to maximize the whole loops. Standardization and codes should also be in place in order to respond for all the next demand, and also some public support, including incentives, maybe subsidies, in order to have a good price and good competitive for hydrogen. The last is research and development. It's necessary to keep ongoing in order to lower the prices for the technical issues, and also to have big competitive within the other source technology. So this I finish my presentation, and thank you very much for your. Yes.
Thank you very much, Mr. Fatian. This is very promising. We'll move now to Ms. Al-Hamrawi. So P2P projects are not only on papers and on feasibility studies. So Ms. Hanan will present us, let's say, concrete project which is taking place right now. And she will talk about also projects that are under development for her company.
Hello, everyone. As we said, power-to-power is something that is quite promising for the electricity mix, and mainly to overcome from the intermittency of the renewable. And that was what HDF has looking for. When we started the development of the company, it was to search how we can take the renewable that is intermittent into non-intermittent and have a dispatchable power plant coming from the renewables. I will start just quickly to introduce who is HDF. So HDF, we are based in France. It's a company that is developing a hydrogen infrastructure with a specialty of using hydrogen as a way to store the renewable energy, so to make this power-to-power application. And we are also manufacturing our own megawatt scale fuel cell system that will be the mean to repower through the hydrogen into the electricity grid. And we are present today in more than 30 countries. And we are happy also to launch our subsidiary in Morocco. The name is Hydrogène du Maroc. We are HDF, it's Hydrogène de France. So it's a good name to start also the development of our activity in Morocco. So here is the flagship solution that we are developing at HDF. What was presented before, it's a way to do the power-to-power when the infrastructure will be ready. It means when there will be full of hydrogen, the pipeline, the storage. For sure, it will take time. So what we did at HDF, it's don't wait for the infrastructure, and let's develop some turnkey solution, some power plant that can be standalone and not connected to the infrastructure to start this hydrogen economy. So this is the solution that we are developed. It's called Renew Stable, for renewable stable. It combines different way to produce electricity. So the first one is the renewable asset. So we need PV or wind, depending on the location. Then part of this electricity will be directly injected to the grid. Part of it will be injected to the electrolyzer to produce hydrogen on site. Then it will be stored on the metallic tanks, very basic. And then after, we will have some battery. So we don't think at HDF that the battery will be the opposite of hydrogen. It's a complementary to hydrogen. The battery will be here for the peak demand. It's very reactive, so we need battery in our project, same as we do for the mobility. Electrical car tomorrow on hydrogen will use also the battery. So we will have battery, and then after we have these fuel cells that will take the hydrogen and to produce electricity when the renewable plant is not available. So if we take the example of the solar, when there is no sun, this is the hydrogen chain that will take the lead, and the fuel cell will generate electricity, for instance, during the night. So the key benefit, as we explained also earlier by my colleague, this kind of power plant, they are going to work as a thermal power plant. It means that we are going to deliver to the utility grid a firm power during the day, during the night. On some of our projects, so we have X megawatt during the day, X megawatt during the night. We sign what we call the PPA, the Purchase Power Agreement, with the local utility grid for more than 20 years. So this power plant is the new generation of the renewable power plant that we have today that is dispatchable. So you can control what you want, and the power plant will deliver the power that you will requested. So here, just to show you some track record on the project that we are developing. So we wanted to share today that we are not on the pilot phase. We are at industrial phase today at HDF. On the extreme left of the slide, this is the project that is under construction, the first one that HDF has developed today. It's in French Guiana. It's a part of France near Brazil. We have a power plant that is today delivering 10 megawatt during the day, 3 megawatt during the night, with a PPA signed with the local utility grid that is EDF SEI. And we have also financed by the private sector this kind of project. So this is something very important to mention because as of today, hydrogen, the key issue of the hydrogen is, of course, the price and who is going to offtake the molecule. Here, we don't offtake the molecule, we produce electricity through the hydrogen. So we are on a business model that already exists. We have a PPA, and we can also finance that by the project finance scheme. It means part of the equity and part of debt. So when we go to debt, we need to think about the bankability of our project, and we need to show that to the private bank that our project has reached a technological maturity enough in order to have the loan to finance the project. So we are very proud, and we have received a lot of awards for this kind of project in terms of financing. So this project has been financed by some private banks, like for instance, the Japanese one, Sumitomo Corporation Bank, but also some French ones. And we have welcomed also two main investors, Meridiam, it's a French investor, and an industrial player, French one as well, Sarah, that is the refinery of the Caribbean island in France. So this project is also, when you develop this kind of project, you need someone that will build the project. Because at HDF, our specialty is to develop projects, to organize the financing, but not to build the project by our own. We are not an EPC, an engineering project construction company. So this EPC has been selected for this project. It's Siemens Energy, the German company. This also shows the maturity of this project, because when you have a company like Siemens to enter into this project, they need to check also the maturity of the technology, so mainly the electrolyzer and the fuel cells. And we have other project that is under development as well. So in Indonesia, we are running on a pipeline of 20 projects. Those projects has been supported by the American government. The US, they are investing a lot in Indonesia. In Indonesia, you have thousands of islands. So our solution makes a lot of sense because there is a lot of islands not connected to the main grid, relying on the diesel genset. So we can progressively replace all these diesel genset by our solution based on hydrogen. We have also a project in Namibia. Namibia, as you may know, they are mainly dependent on the electricity coming from South Africa. And in South Africa, they are facing a lot of challenges today for their electricity. There is a lot of blackout, sometimes more than 10 hours blackout. So this solution that we are developing, that is a standalone solution, we can work as I would say off-grid. So we can bring to Namibia also some independency regarding the electricity. And then after, we have two other projects under development in the America region, one in Mexico, in collaboration with the local utility grid, CFE, and then one in Barbados in the Caribbean. So this slide, it was really to show you that we have one that is under construction, so it means financed. It means that it will be in operation next year. Those are ones that are coming. The power-to-power on some region, of course not on all regions, but power-to-power can be a very good solution to implement hydrogen. It's not pilot project, they are industrial project. So this is the reality as well, that this kind of project are working. And it gives also, if I take the example of Namibia, some good start for the hydrogen economy locally. In Namibia, they want progressively to produce massively hydrogen for the export, but the export will take some time because we need to find the off-taker, we need to build the infrastructure for the transport. We have the decision just before regarding the hydrogen carrier. So for Namibia, this kind of project that is integrated locally, they can, with our project, start all the training, all the regulation associated to the hydrogen that will prepare then after the next big project for the H2 production. Just to show you on the next slide, where we are also present, it shows you also where there is the potential today for the hydrogen to power application. So mainly it's in South America, but also in the US. US is one of the countries that there's a lot of people they don't know, but they rely a lot on the diesel genset. So they will need to decarbonize. So one of the solutions that was mentioned by the US government will be to use the hydrogen as a way to store the renewable energy. We have countries like Chile or like Brazil, they are developing a lot the renewable energy. So it's also a challenge for the electricity grid. As was mentioned by my colleague from ONI, when you're the utility grid, the renewable energy are not always something nice to you. It's sometimes a nightmare. So our solution is very good for this kind of country that they are developing massively the renewable energy. Then after we have the Asian region with a lot of islands, so as explained, not connected to the main grid, so the hydrogen solution makes sense. Australia is quite of the same as the US, a lot of diesel genset as well running in Australia. So basically this is our presence where we develop projects and where we believe that that hydrogen is a good solution for store the electricity. And hopefully for the next year, we can add something in Morocco. We still need to discuss with Oni and Mazen, but we truly believe that there is some opportunities as well in Morocco. To make all of this project, of course, we need a technology because electrolyzer will be here to develop and to produce the hydrogen. But then after, when you have produced the hydrogen, if you want to re-electrify, you need a solution to do it. We have developed our own fuel cell system at megawatt scale. That was also a challenge because at the time when we started in 2017, the fuel cell manufacturer was only focusing on the mobility sector and the light vehicles, mainly bus, train, commercial vehicles. So really not connected to how to distribute the generation from the fuel cell and how to connect to electricity grid. So that was the main challenge that we overcome. And for sure, the R&D is a key on this kind of project. You need to have a technology ready to deliver such amount of electricity to the grid and the connection to the grid for very different places. So the grid in Indonesia is not the same as in Morocco, is not the same as in Mexico. So you need also to adapt your solution to the different grid. So we have this solution. It's today our solution is 1.5 megawatts containerized solution, and we are currently developing a 10 megawatt system in order to provide the large scale project that we are developing today. For example, in South Africa, we have a project under development with Eskom, the local utility grid, for 50 megawatt, 50 of fuel cells. So coming from 1.5 megawatt, it will be still a challenge. So we need to also upscale the unit of the fuel cell that we are developing. I think. Yeah, I think that that is for my presentation. I just wanted to end that the power to power sometimes can be challenging when you think about the cost. Don't think like that. We don't deliver the same services as a renewable asset. We deliver the same services as a thermal power plant. So for sure, the services has a cost. Hydrogen is still expensive, but we all agree that there is a lot of movement today to reduce the cost of the technology, but also we need to reduce the cost of the financing, because financing it's also a challenge when it comes to this kind of project. And we need also that all the infrastructure will be ready, because today we are developing our own hydrogen production, but if tomorrow there will be massive hydrogen transported by pipeline, stored on the salt cavern, we can use this without developing our own hydrogen and just work like the gas power plant are doing today, and plug and play our fuel cell solution. Thank you very much for your attention, and I will let the floor to my next colleague.
Thank you very much, Hanan. Congratulations for the financial close of this great project, and looking forward, let's say, to after the commissioning to have the lessons learned from this first utility scale project. We'll turn now. I'll give the floor now to Mr. Raul Manzanas. So, Raul, please, can you tell us about the new business models that this technology of power to power enable in the energy sector? And I know that, let's say, over your experience, you have also been in charge of some research and development. So can you tell us about, also, we have heard about the drawbacks, we have heard about the challenges, the round trip efficiency, the response time, etc. Can you tell us about, in terms of R&D, what needs to be done to make this technology a great, it's a bigger project?
Yes. Well, first of all, thanks to the organizers. I'm really very pleased to be here. I've been in the renewable sector for 20 years, so part of my experience was in research and development. And when I was invited for this power to power session, I was thinking what to say. And every single time I'm just hearing people, I'm trying to, in a certain way, convince my mind in terms of what to say. And hearing my colleagues right here, one of the questions that I would like to ask to everyone, or to everyone to ask themselves, is, do you have a fridge at home? I would say majority of us, yes, we do have. Did you have, or did you suffer a situation that you have been without electricity because of whatever for 6-8 hours? What was your mindset? What were your thoughts at that point? What was going to happen with your meat and with your food and with the rest of the things? And we are discussing about power, about electricity. Which is the value that you give to power, to electricity at that point of time? And that is something which is very important, because we have seen in graphs that basically renewables have been dropping down cost. I remember when I started in renewables that the discussion was the wind going to be competitive against gas, coal, or whatever? Solar was skyrocketing at that point of time. And now no one discussed that. It has been massive volume production. It has been massive development in terms of technology, and all that has taken to the point where we are. But there are some drawbacks, obviously. Nothing is perfect in this world. So we do have a generation source which could enable us a pretty nice and decent cheap energy, independent in most of the cases, but is variable, and we need to solve that. And that is changing completely all the markets. And one of the things that we have to secure is basically that the energy is a primary thing for everyone, for most of the applications, and you need 24/7 availability of energy. And that in itself needs that we have to power or to give some sort of backup services. And that is where I think power to power is going to be. Basically, the applications that we are discussing by using hydrogen directly to combust or to fire gas turbines, or whichever other technology advance that we do, or even in the case of fuel cells. And as I said, I think it's not a matter of how much it costs the electricity. It's the matter of what will happen if you do not have the electricity at that point of time. What are going to be the consequences? So I think that is a must. And I'm not scared, or I should not be concerned about what has been the price, especially while we have been just going through the last 2-3 years when we were seeing the Ukrainian war and how the prices of electricity have been skyrocketing. We were seeing prices in France, a nuclear-based country, with prices reaching almost 1,000 euros per megawatt hour. That is crazy. I've been seeing that, for example, in cases like Texas or even Alberta, in certain occasions where there were high peak prices because of special conditions. But during this time, we have seen those prices being stable and at that such of levels for more than almost 1 year. So we have to make our own mind in terms of what we want, what are we looking for. And apart from that, also we do have the climate change, which is something which is going to oblige to everyone to change the way we live and the way we produce electricity and the way we power our different applications. So I think that is a must. Technology-wise, I think, and as I was mentioning to you, 2008, we did develop in between Acciona Energía and Shaft at that point of time, the first ion lithium battery to be connected with a PV plant in 2008, connected in Spain. High response, 1 megawatt ion lithium in a container. And at that point of time, we were just starting the market. Today, batteries containerized, I'm not going to say it's a commodity, but it's something that you can use. So we will see that prices will go down. I don't expect, and if someone is thinking that they will have these backup solutions with power at the price of 30 euros per megawatt, please wake that guy because he is dreaming. Absolutely. That is not going to happen. But that is not a problem because basically that is a backup service and you need that. So I think you have to complement everything, all the different pieces of the puzzle with different applications, different components, and with that, you can have a full integrated and valid system which will power our countries and our society. And that is basically the aim of all this. I don't know if I have responded to your question.
No, that's clear. That's clear. That's clear, Raul. Thank you very much. I think everyone is hungry here. So let's conclude this session. So, well, I mean, from the presentation we have seen, we can say that, I mean, this application looks like the perfect solution, let's say, to tackle the issues we have at the grid level, like the grid balancing and also the excess of renewable energy, let's say, that we have sometimes during the day. What we can say also is that this application is no more on the papers and no more on the feasibility studies. There are projects taking place right now. So I think the companies are now paving the way, let's say, to make it at utility scale and bigger project and more projects. So thank you all. Thank you, great panelists. Thank you, the audience.